All right, day 2 of section 3.5. We're going to continue writing equations of lines, but they're going to be equations of lines that are perpendicular or parallel to a given line. So let's review a little bit. What do we know about slopes of parallel lines? What do we know about the slopes of parallel lines? They have the same slope. If you have two lines and they happen to have the same slope, those two lines are parallel lines. And then what do we know about slopes of perpendicular lines? They have opposite reciprocal slopes. Opposite meaning the sign would change from positive or negative. It's just going to be the opposite sign. And then reciprocal meaning you'll flip the fraction. So if your slope is 1 over 2, the reciprocal of that is 2 over 1. And then it would have the sign change to positive or negative. So what do we know about parallel lines? They always have the same slope, and perpendicular lines always have opposite reciprocal slopes. Let's also look at the special types of lines, our vertical lines and horizontal lines. If it's a vertical line, remember the slope is going to be undefined. Meaning that our run, our difference of x's, would be 0. So we can't divide by 0, so it's a vertical, it would be undefined, so vertical lines are always undefined. Now the equation of a vertical line is going to be x equals some number. X would just equal some number. Since it's a vertical line, it's going to cross through the x-axis. It'll never cross through the y. It'll only cross through the x-axis, and it will cross through at some point. So maybe it crosses through at the x-axis at positive 2, so x would equal 2. Just goes on up and down forever at x equals 2. Now your horizontal lines, the slope, m, is going to be 0. And that's when your rise is 0. So you have 0 over a number. And your equation of a horizontal line is going to be y equals a number. So a horizontal line will always cross the y-axis, but never cross the x-axis. So it's going to be y equals, and then wherever it crosses the y-axis. So let's look at some examples. Example number 1, we need to write an equation of the line that passes through the point P and is parallel to the line with the given equation. So we know a point and we have a line. That's our given information. We need to write an equation based off of that of a line that is parallel. So if it's parallel, we know it's going to have the same slope, and our slope is 2. So our new line, our parallel line, is also going to have a slope of 2. So we know the slope, and we know a point. We can use point-slope form. So we have y minus 1 equals our slope 2 times x minus negative 1, or x plus 1. And then we just need to write this in slope-intercept form, and we've got our line. So y minus 1, let's distribute the 2. 2x plus 2, and then add 1 to both sides. So our parallel line that passes through negative 1, 1 would be at y equals 2x plus 3. Now for letter B, we have a point at 5, 0, and our line is y equals 4x plus 1. Remember, this is, again, we're writing a line that is parallel to it, so it will have the same slope. Here our slope is 4. So we know the slope, we know a point, we can use point slope form. So y minus 0 equals our slope of 4 times x minus 5. So we just need to distribute our 4. Y minus 0 is just y. So 4x minus 20. Y equals 4x minus 20. And that would be the equation of the line that is parallel to y equals 4x plus 1 and passes through point 50. Okay, one more example with parallel lines. We have a point at negative 3, 0, and our equation is, our line is at y equals 8. So what is the slope of y equals 8? Well, if we go back and look at our special types of lines, when y equals a number, it's a horizontal line, and m equals 0. So we have y equals 8, y equals a number, so it's going to be a slope of 0. And the way we got to y equals 8, we likely would have had an equation that looked like slope-intercept form, like y equals, but when it's 0x, 0 times any number is just 0. So we can leave that off, and it's just y equals 8. So we have a slope of 0, and it needs to pass through the point negative 3, 0. So if we plug in our numbers, y minus 0 equals slope of 0 times x minus negative 3. And so 0, when we distribute the 0, everything in there just becomes 0. So it's just y equals 0. That is a parallel line to y equals 8. And it's going to pass through negative 3, 0. All right, now let's do that with, or for perpendicular lines. So we have a point and a line, and we need an equation of a line that is perpendicular to the given equation. So what do we know about slopes of perpendicular lines? They are opposite reciprocal. So if we see a slope of 1/2, the opposite reciprocal of that, or the perpendicular slope, is going to be negative 2, or negative 2 over 1. So our slope of our new line is going to be negative 2, and we're going to use the point 4, 2 in point slope form. So y minus 2, bring the 2 down as our y, 1, equals slope of negative 2. That's our opposite reciprocal slope. times x minus 4. Then distribute the negative 2. Comes negative 2x plus 8. Add 2 to both sides. And y equals negative 2x plus 10. And that would be the equation of a line that passes through point 42 and is perpendicular to line y equals 1/2 x plus 4. So let's do that for letter B. We need to pass through point 3, negative 2, and perpendicular to line y equals negative 3x plus 2. So in our given line, our slope is negative 3. So the perpendicular slope is the opposite reciprocal of that. Opposite meaning opposite sign, so it's going to be positive. Reciprocal, flip the fraction. So 3 over 1 becomes 1 over 3. So we're going to use the slope 1 over 3 with the point 3, negative 2. So y minus negative 2 equals the slope of 1 over 3 times x minus 3. That becomes y plus 2 equals, distribute the 1/3, so 1/3 x, and then 1/3 times negative 3 is just going to be negative 1. And then we need to subtract 2 from both sides. So y equals 1/3 x minus 3. So that would be the line that passes through point 3, negative 2, and is perpendicular to line y equals negative 3x plus 2. And then one more example. It needs to be perpendicular to the line y equals negative 3 and pass through the point negative 5, negative 3. So if we know it's got to be perpendicular to y equals negative 3, y equals negative 3 is a horizontal line. So we need a vertical line. Vertical line's equation needs to be x equals a number. Our x value is negative 5. So if our x value is negative 5, that means our equation is just x equals negative 5. And that would be our answer. If we tried setting this up like we did the others, we identify our slope here as 0. Our perpendicular slope would be undefined. We can't write an equation with an undefined slope. So it is just x equals negative 5. So if we tried plugging in undefined as our slope into a point slope form, it's just not going to work that way. So when you have y equals a number as your equation and you need to write an equation of a line that's perpendicular to that goes through a point, just take the x value of that point, which is negative 5. And if we did it the other way, if we have x equals a number as our equation and we needed a perpendicular line that goes through a certain point, it would be y equals whatever your y value is. So like what we did in our previous example with the parallel line, where we just pulled the y value of that because the slope was just going to be the same. So when you have a slope that's undefined, you can't write a normal equation. That's why it's x equals a number instead of y equals a number. So that's it on the notes. Make sure you do your homework.